Hi, in this video we're going to be examining the characteristics of Venn diagrams. Now may have been exposed to Venn diagrams in the past, but we're going to take a little bit of a closer look at them and see how we can find different values of a given diagram. So in our example here, what we see are some models of how we could have different elements contained within a situation that we're looking at. Now, if you notice, there's a U that's just outside of the circles, contained within the rectangle, basically. The U represents our universal set. And the universal set is basically the set of all elements, whether it has A, B, or maybe even none of them, right? This is just containing everything. So if we have two different things contained within a universal set, maybe A and B, maybe the things that we're looking at are the people who have CDs versus the people who have MP3s, right? Maybe A is the people who have CDs, B is the people who have MP3s. Maybe people don't even have these types of music to begin with, so they'd be included outside of the circle, but they're still within the universal set. Okay? So in terms of just what we can possibly have, you can see that maybe there's some people who just have CDs. Maybe they're just people contained within element A. So we might have a subset of people that just have A. Or maybe we just have people that download MP3s. And so we'd have element B just on its own. Or maybe we have a group of people who have CDs or MP3s, right? Maybe it's just a mix. And so you might have an element of A or B, kind of like that. You have those possibilities. Or maybe just people don't listen to music, and maybe you just have people who don't own any of these things at all, and they'd be outside. And that would be basically like a null set, an empty set, basically. This is what we call the empty set. Okay, so you could have those possibilities as well. So I'm just kind of giving you some different scenarios that may come into play as you're taking a look at these Venn diagrams. Now, the diagrams that you see down below, the three diagrams, are actually very specific situations here. Now, if we again take a look at A versus B, and if you see the symbol here, this means that you're looking for the intersection of A and B. And the intersection is basically for where A and B overlap. You're looking for when A intersects B. Like that. Okay. In other words, maybe another way to phrase this is maybe what you're looking for is an A and a B to occur. Excuse me. So as we take a look at this, where do A and B occur? Well, this would be all the area of A, and this is all the area of B, but where they occur together would be this dark area right here. That's going to be A and B. Okay, so that's going to be A and B right there in the middle. If we take a look at the upside down symbol of intersection, or maybe it looks like more like a U to you, this is actually called the union of A and B. And union is either looking for A or B. You can have either A or B. So maybe it's people who own CDs or own MP3s. You have different choices there. You don't have to have just one item. You can have one or the other. Okay, so in this case, you can have A, or you can even have B. You can have all this. So you can see here that the difference between the amount of people contained within these subsets, you can definitely see that AND contains less people. You kind of get this shape that looks like this. But if you have the word OR, you can have the entire two circles, and it kind of looks like a peanut, right? So kind of like that. Okay, so you can have, notice how this is kind of like a bigger subset compared to the intersection. Okay, versus the other case here. Now, if you see a line, this basically means not A. And so not A is basically, if we're saying that this is A, everything that's not A is everything not in the circle. So that'd be everything outside. We'd be shading everything out here. Okay, so this is the set of elements not A. So as we take a look at what we have just talked about, we can actually develop something called the inclusion-exclusion principle. It's to say that for any sets A and B, n represents the number of elements. So we're saying here the number of elements of A, and then because we have a union symbol there, A or B. So we're going to create a formula saying the number of elements of A or B. Now keep in mind, I'm going to try and create this formula almost like with a picture, with a diagram. Remember that the number of elements of A or B, which is the union, kind of like, as I said earlier, kind of looks like a peanut, right? So I'm going to go ahead and say that the number of elements of A or B, which kind of looks like a peanut, right? So this is the number of elements of A or B. It's equal to, well, how do we create it? Well, what we're using here is the number of elements of A, the entire circle here of A. Okay, so it's equal to the number of elements of A. And then what else did we do? Well, we also combined it with the number of elements of B. We're adding on this full circle, which is the number of elements of B. However, when you add two circles, notice what happened. You almost created like this overlap, right? You added this section of A, and then you added it again for this section of B. So because you have accounted for this area, you can see it's accounted twice. We need to actually make sure we take out one of those sections. There wasn't like an overlap. So we want to take out the overlap. And so we subtract that middle section. What's that middle section again? Well, if you recall from our first diagram, the middle section is talking about the intersection of A and B. Oops. So as I go over here, I'm saying minus the number of elements of A and B. So this is going to create our inclusion-exclusion formula that you can use to find the number of elements contained within a certain part of the Venn diagram. And in our next video, we'll take a look at some examples of how we can do that.